Hey, guys, so today we're going to do the simulation of dust. Before moving further, make sure to hit like and subscribe to my YouTube channel. You can also support me on Patreon. I'm going to release the Vellum multi-layer cloth sim after this RBD tutorial. Let's dive into Houdini. Take an object merge and import the out_debris null. Take an attribute VOP node. We need to clamp the edge. Take a clamp and bind export node. Connect the clamp to the global age parameter. Now export the age attribute. Take an attribute wrangle node. Since we already have density attributes coming from the debris source node, we need to modify it a bit because we had clamped the age value. Write this fit function. So here, when the new particle is born, his age will be 0, so we need dense smoke at that point. As the point goes older, the smoke will fade off. That's why here in this vex, the particle whose age is 0 will have a density value of 1, and when the particle will get older it will have a density of 0.1. Now copy the delete node from the debris layer and paste it here. Now again take an attribute wrangle. In this wrangle we are going to create an ID attribute and a float end attribute with the value of 0. Duplicate the wrangle node. In this wrangle set the end value as 1. Now write this code. Here we are going to subtract the position based on its previous frame velocity data. We are going to use velocity, time increment, and a custom parameter. If you press the plus icon and set the value as 1, you can see the points are moving back to their previous frame position. Set the value of the frame back to 2.5. Now merge both the wrangle. Take an add node. Switch it to by the group. In the add method select by attribute. And in the attribute name write ID. Now add a rest position null. Take a resample node and set the length to 0.05. Take a point jitter node. Set the scale to 0.1. Now again take a resample node and set the length to 0.05. Take an attribute wrangle node and write this code. This code will blend the noise value using the rest attribute that we had created above and the end attribute. The end attribute value of 0 will have the same position as the rest, then it will blend with the noise toward the value of 1. If you template the building, you can see in the starting the lines are attached to the broken pieces, so the smoke will look like it emitting from that pieces. Take an attribute noise. Change the attribute name to float and write density. Actually, we need to use an older version of attribute noise. From the asset bar select the older version. In the mode select multiplicative, since we already have the density attribute, we are just adding some noise to it to feel like more natural. In the signature select 1D. Turn on animated and remap noise. In the minimum value write 0.3 and in the maximum value write 1.2. Set the element size to 0.5. Now take a volume rasterize attribute node. In the attribute select density. Currently, the point scale is too big, that's why the source is too blobby. Reduce the particle scale to 0.1. Set the voxel size to 0.06. Take a volume wrangle and write the code. We just multiply the density by the given value. Click on the little plus icon to create the parameter. Set the value to 3. Now add a null. Before setting up the DOP network, let's create the collision for the building. Take an object merge node. Import the proxy RBD null. Take a blast node. Based on RBD_name select metal, concrete, and window frame. Turn on delete non-selected. Now take a VDB from polygon node. Since we already have the velocity attribute, we need to create the velocity VDB also. First, reduce the voxel size to 0.075. Now click on the plus icon. In the attribute select point V. In the VDB name write vel. In the vector type select displacement/velocity/acceleration. Take a visibility node and hide the velocity VDB from the viewport. Now cache it to disk. If you have a multi-core CPU, then you can use this method to cache faster. Right-click on the file cache node and select Allow editing of content. Go inside the file cache, then again dive inside the top network. Now select ROP geometry node and switch to the ROP fetch tab. Now break the channel for all frames in one batch by pressing Ctrl plus Shift plus left click on the tick box. Now I'm going to cache 15 frames per batch. Now in the frames per batch, you can choose as per your CPU cores. I have 10 core CPU since by default this uses the half core from all your CPU cores. Means if you have 6 cores CPU then it will use only 3 cores. Now hit the save to disk in the background button. Press save and continue. Since I have 10 cores, so now it will open 5 new Houdini instances in the background and it will cache. Add a null once the cache got finished. Take a timeshift node and freeze the first frame. Add a bound node. Take a null and named it out_bound. Cache the volume source also to save some time while simulating. Since our building is big, the simulation will take too much time and could use 64 plus gigs of RAM. So to avoid this we are going to scale down both the source and collision geometry. After the sim, we will revert it back to its original size. Take a transform node and scale it down to 0.2. Now right-click on the transform node, go to action and create a reference copy of it. Now connect the reference copy to the collision. Take a DOP network node. In the first input connect our source, and in the second input connect our collision geometry. Let's create a basic Pyro setup. Now to set the container size, right-click on the size parameter, then go to Reference and select Scene Data. Now expand our out_bound null. Again expand the bounding box and then select the size and hit Accept. Do the same for the center also, instead of size select centroid. Take a gas resize node and connect it to the second input of the Pyro solver. Increase the padding to 1.5. Go to the Max Bound tab and turn off the clamp to the maximum. Now take the volume source node. In the Initialize menu select anything, then again select Source Smoke. In the input select the first context of geometry. Since we only have density attributes, we will feed density in the source volume of temperature. Remove the velocity, we will use collision velocity for smoke movement. First, let's check on which frame the source gets born. So on frame 6, the source gets born, so in the DOP network, we will keep the start frame as 5. Now in the gas resize node set the delay frame to 1. Let's preview and check. So due to buoyancy force, the smoke is going in the upward direction. In the Pyro solver, set the buoyancy direction to -1. Add a ground plane for ground interaction. Now duplicate the volume source. In the Initialize menu select Collision. In the input select the second context of geometry. Since we had given the VDB name as vel, write vel in the volume source also. The simulation will get a bit slow due to heavy collision geometry. To see how the collision is represented inside the solver, go to the Smoke Object node and turn on Collision Visualization. Strange, it's coming like a box. Oh sorry, in our collision source, it has a surface VDB name. So write surface in the source volume also. Cool. So currently this is very low resolution, this collision resolution depends on the voxel size. Take a gas disturb microsolver node. From the asset path select the older version of gas disturb. If you don't know how to enable this, go to Assets, Assets Manager, Configuration, Assets Definition Toolbar, Show Always. In the disturbance write this fit function. We are animating the value from frame 20 to 45. Set the cutoff to 0.5 and the block size to 0.2. For faster preview, remove the collision source. Increase the resolution a bit for better understanding. Go to the Pyro solver and set the timescale to 0.85. Set the temperature diffusion and cooling rate to 0. These two parameters usually used while making explosions or fires. Go to the Shape tab. Reduce the dissipation value to 0.005. Turn on disturbance and write this fit function. We are animating the value from frame 20 to 35. Below you can see the disturbance tab. From there set the cutoff to 2 and the block size to 0.5. Turn on turbulence and again write this fit function. We are animating the value from frame 10 to 30. Go to the turbulence tab, and set the swirl size to 2. Increase the turbulence value to 3. Cool, now connect the collision source also. Set the final resolution according to your PC config. Now take a DOP import filled node. In the DOP network, drag our DOP sim node. Write smoke in the DOP node. From the preset menu, select smoke. Remove all the fields except density and velocity. Take a volume reduce node. Since this is already too small container, if you have a big smoke container it will use a lot of disk space. Using this node will save lots of disk space. Also this node reduces the viewport lag. As you can see here, we are having Houdini volumes that have used 12.5 megabytes of RAM. After the volume reduction, you can see now it just used 3.2 megabytes of RAMs. If you turn on deactivate empty voxels, it will use less RAM. And if you turn on downers and set the value to 2, it will save more space. As you can see, this node doesn't make a vast difference from the original simulation. As you can see, the original sim has a big container that will have some useless data to it. This node will remove all the useless data. Now cache it to disk. For now, I'm just going to cache around 150 frames. You can cache according to your scene. So if you see here, the original sim uses 172 megabytes of RAM, but after the reduced node it uses just 19.72 megabytes of RAM. You can see the disk loading is also too speedy. Now select the transform node and again create a reference copy. Connect it after the cache node. Break the invert transformation parameter and turn on the invert parameter. Now merge all the simulation layers. Set the smoke to a darker color using Pyro bake volume. Increase the viewport volume resolution from the display option. The debris layer is too heavy currently, so for preview purposes, I'm removing it. Let's make a preview. If you found this tutorial helpful, please like, share, and subscribe to my YouTube channel. You can also support me on Patreon.